Hey everybody, today we're going to go over how to graph to estimate ventilatory threshold based on the metabolic cart printout that you'll get at the end of a test. So once you're done in the lab, you'll see that this is all of the data for the testing that you've done. We have time as well as many other variables that are gathered throughout the test for the entirety of the test duration. So for the sake of graphing to estimate ventilatory threshold, there's a few um, variables that we need. Today we're going to be using ventilatory exchange and respiratory exchange ratio. To make it easier for myself, I like to highlight those variables just so I can see clearly these are the ones I'm using. The other variable that you'll need is heart rate, so you can go ahead and highlight that as well. The other thing I like to do to clean up my data before I actually begin graphing is to copy and paste this off to the side so I don't accidentally select anything else. And also because the way that Excel works, if you create a graph, whatever column is on the left will automatically be your x-axis, and whatever column's on the right will automatically be your y-axis. So I like to put the data in this format so that way my heart rate is always on the x-axis, which is what I want for this graphing, and my ventilatory exchange or RER are always on the y-axis. So once I've got the data cleaned up a bit, I can see what I'm looking at specifically for this estimation. Then I can go ahead and select all of my values for heart rate and ventilatory exchange. We'll go ahead and graph ventilatory exchange versus heart rate first, and then after this we'll go and graph respiratory exchange ratio versus heart rate. So once I've selected the data for the two variables I would like to graph first, I'll go ahead and hit insert, and we are going to create a scatter plot, and it'll just automatically format with heart rates on the x-axis and whatever value or variable ventilatory exchange or RER on the y-axis, as long as you've formatted it like this. So once you've got the graph created, you'll see that we have all of this dead space here. So the best way to handle this, you can double click on the x-axis values here, go to the axis options, and under the axis options, you'll see the bounds minimum. Here I can tell that my lowest heart rate throughout the entirety of the test was 78. So I'll put the minimum bound of the graph at 70, just so now you can see once I actually hit enter there, we're able to see these data points much more clearly instead of them being bunched up on the right side. So this chart here is my ventilatory exchange versus heart rate. So heart rate on the x-axis, ventilatory exchange on the y-axis. Next step after you've created this is to go ahead and create the next one, and then we'll compare the two and look for an actual ventilatory threshold. So to create the next one, I'll go ahead and select all of my data for heart rates. And here I'll also select RER, so I'm just holding Control and selecting the RER column. And again, we just go over to Insert, and we'll insert a scatter plot here. And again, you'll see we have all this dead space that's just cluttering up the graph on the right side, so I can double click my x-axis here, the values, go to my axis options, and over here under axis options, again, I'll set the minimum bounds to 70. And again, you can see that just clears this space up to be able to see these data points much more clearly. So next steps to actually, well, first I'll label this RER versus heart rate so I don't get confused. Next steps after you've created the graph is to try and find the ventilatory threshold. So when you're trying to find the ventilatory threshold, you're looking for the deflection points in this data where the increase in your ventilatory exchange or the increase in your respiratory exchange ratio is no longer linear with your heart rate. So the best way to do that is to insert a line and then draw to estimate the line of best fit for the first half of your data. So if I'm looking at my data here, starting off, that looks like a pretty good line of best fit, maybe something a little more like that. So you can see this line is going through all of these data points in the beginning very well. However, once we get to a certain point, they start to deflect away and no longer match that line of best fit that we eyeballed here. So then at that point, you will insert another line for the data that has deflected away. And we'll say that's a pretty good line of best fit. And now at this point where the two lines intersect, where this breakpoint occurs and there's no longer linear increase, that is our ventilatory threshold. So you can see where these lines intersect here. I'll put another line going down to the x-axis. And that is occurring at about a value of 160 beats per minute. Remember, heart rate's on the x-axis here. So that is our ventilatory threshold according to ventilatory change in heart rate. We'll go ahead and do the same thing for the RER and heart rate. So we'll draw our line of best fit again for RER and heart rate. And take a second to make sure that it looks pretty good, like an actual line of best fit. Okay, and then again here you can see our RER starts to deflect, increase a little more rapidly with our increasing heart rate. So we'll draw that line through those data points just like the previous. Again, centering it pretty well so it looks like it intersects with those data points perfectly. And you'll see here that we again have an intersecting point between the two lines. Wherever that intersecting point is, again, once more, we will draw the line down to our heart rates. And you'll see here, should be a very similar value between the two. In this one, I would say it's 160. In this one, maybe just a little above, maybe 162. And for all intents and purposes, that would be a good, accurately estimated ventilatory threshold occurring at a heart rate of around 160 to 162 in this individual.